Okay, so we know what all of these answers are, and that's our goal, is to get it to look like these answers right here. And so we're going to take this stuff to start with and try to manipulate it so that we get cosine or sine or tangent or cotangent. And so we're starting off, we'll do number 66 first. 4 cosine squared equals 1. And I even moved on this first step, moved the 4, divided both sides by 4, so that we have cosine squared is 1/4. So what you do to one side, you of course have to do the other, like regular algebra. And then we don't know what cosine squared is, but we know what cosine is. And so if we take the square root of both sides, actually move it right there so we can see as much as possible. And so if we take the square root then of both sides, so the square root of cosine squared and the square root of this, well, this could be positive or negative 1/2, because if we square negative 1/2, negative 1/2 times negative 1/2 is also going to give us positive 1/4. And so it could be positive or negative 1/2. And so then we go back and we look, okay, when is cosine either positive or negative 1/2? And we have to do it between 0 and 2 pi. These solutions are only between 0 and pi. They go all the way up to pi. But we can add another pi to them to get the other one. So we want to see when it was 1/2 or negative 1/2, and that's on the cosine. So here's positive 1/2, and that's pi over 3. And since it's put it in pi, it wants it expressed in pi instead of degrees. So 1/2 is pi over 3, and then negative 1/2 is 2 pi over 3. And so my answers are pi over 3 and 2 pi over 3. But it wants us to keep going because it wants us to go all the way to 2 pi. And so if I add another pi, I'm going to get the same answer. And so a pi plus 1 pi over 3 will be 4 pi over 3, 4/3 pi. And then if I add pi to this, I'll get 5/3 pi, or 5 pi over 3. So those are my 4 solutions. And then for, oops, I jumped to the wrong one, but it has the same 4 solutions on 66 as it does on 70. But 68, this is secant squared. I can't write very well. But secant squared x is equal to 2. And secant squared is 1 over cosine squared, because secant is 1 over cosine. And so 1 over cosine squared equals 2. And then I kind of cross-multiplied in my head, or flipped both of them. You can always flip one side as long as you flip the other. And so this is cosine squared, and now this is 2 divided by 1 is still 2. So now we flip it, and that's 1/2. And if we take the square root of both sides, this becomes plus or minus 1 over the square root of 2. Or another way of doing that is expressing that as the square root of 2 over 2. Because if we multiply the numerator and the denominator both by the square root of 2, the square root of 2 times the square root of 2 becomes just 2 in the denominator, and you have the square root of 2 in the numerator, and you keep the plus and minus. And then we go back to our chart, and we're still looking at cosine. Cosine's quite popular on this one. So cosine, we want the square root of 2 over 2, or negative square root of 2 over 2. So here we have pi over 4, and then 3 pi over 4, and then if we go back around and add pi to this, this becomes 5 pi over 4, and this becomes 7 pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then for 70, I'm going to divide both sides by 3 to get the cotangent by itself, and then I'll probably flip it to make it tangent, but I'll have to flip the other side too, of course, and then I'll take the square root of both sides, and that's what I do here. So cotangent squared is 1. Oh, I already moved here. I've already moved the 3 over to the other side to make it 1/3, and then I flipped 1 over tangent squared, so is 1/3, and so I flip them both, and then I take the square root of both, and I've got plus or minus the square root of 3, and this is for tangent, so we'll go, and I always say TAN, and that's what I've always seen too. I thought it was funny that this chart said TG. I always see TAN, but that's what it means, tangent. So square root of 3 or negative square root of 3, and that is going to be pi over 3, 2 pi over 3, and then if we wrap back around and add pi again, that will be 4 pi over 3, and then this one will be 5 pi over 3. And so pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And then the last one in this section, I'm assuming you wanted me to do the circled ones. The last one in this section, I had to factor. So, and you might notice that I use x instead of theta everywhere because I can't write theta very well. So, but it doesn't really matter, x or thetas. Either one is fine. But you can kind of just treat cosine x as if it's just x, and factor here. This is going to factor nicely as a quadratic, and so cosine squared x minus cosine x plus 2. I knew I needed a positive 2, and so negative 1 and negative 2 will multiply together to give me the positive 2, and I also know I need the 2 cosine squared x at the beginning, so 2 cosine x and then 1 cosine x will give me that, and then here the outsides will give me negative 4 cosine x, and the insides will give me negative 1 cosine x to add together to give negative 5 cosine x. And then we solve for each of these. We'll say when is this 0 and when is this 0, because if this is 0, then 0 times anything is 0. Or if this part's 0, then 0 times anything is 0. This is how we solved quadratics back in algebra, like all the time, is that we would factor, set both equal to 0, and solve for them. And so 2 cosine x minus 1 equals 0, or in other words, 2 cosine x is equal to 1. And then here 1 cosine x minus 2 equals 0, but if we put the 2 on the other side, it becomes positive. So cosine x equals 2. Turns out that can never happen. That's like, can't happen. We can look at our chart back up here, but it doesn't happen. But this one, cosine x being 1/2, does happen. And so we look at the cosine x row again for the third time, and we see it's 1/2 or negative 1/2. I think, is that, wait, oh, I did this answer wrong. So it's only positive 1/2 here. So the 2/3 and the 5/3 shouldn't be there. Sorry about that. It won't let me write on top of it. But so there are only 2 answers to this one, to my knowledge, because I don't think this is solvable. But the cosine x is positive 1/2, and so it is pi over 3, and then you add another pi to that, and that becomes 4 pi over 3. So I only think there are 2 solutions to this last one. I could be wrong because it has been a long time since I've had trigonometry, so I could be wrong on these, but I don't think I'm wrong on all of them. That last one, I'm reasonably sure that reasonably sure that cosine x can never equal 2, but again, it's been a long time since I've done any trig. 12 years, it's been 12 years. And so I could be wrong on that one. And this one, I did what? Okay, yeah, basically use some algebra. So we started off with our original problem. Is that what it looked like? Square root of 3 sine x plus cosine x equals 0. And then I moved the cosine x over to the left, subtracted cosine x from both sides. In other words, so square root of 3 sine x is equal to negative cosine x, and then I divided both sides by square root of 3, and see you see it here too, and I divided both sides by cosine x, so that I could get all the x's together, and sine x over cosine x is just tangent x, and then that leaves me with a negative and then 1 in the numerator and square root of 3 in the denominator, or when I multiply both the numerator and the denominator by the square root of 3 to get radicals out of the denominator. We don't like radicals in the denominator. That becomes negative square root of 3 over 3. So tangent of x, that's sine of x over cosine of x, is tangent of x, is negative square root of 3 over 3. And when we go back, and look at our table, it left it as 1 over square root of 3 and negative 1 over the square root of 3. So we could have just stopped up here. But I only want the negative ones. Yeah. I only want the negative ones. So 5 pi over 6. But also we add pi to that because we want between 0 and 2 pi, and so 5 pi over 6 and 11 pi over 6. 5 pi over 6, I should have squared both of these. 5 pi over 6 and 11 pi over 6 will both give you the negative 1 over square root of 3. So that's 74, and then the last one, I'm going to do much the same thing. Divide both sides by cosine to make this tangent, and that leaves just 3 all by itself on this side. Again, we started with 3 cosine squared equals sine squared. This time we've got squared stuff, so we do have to take the square root, and we do have plus or minus, and that gives us 4 solutions. But yeah, so tangent squared here, 3 here, take the square root of both sides, so we have plus or minus. And of course I forgot my square root of 3 when I took the square root of both sides, and so I had to put that back in there. And so positive or negative square root of 3, and it is, tangent, so we go on the tangent row, and here's positive square root of 3 at pi over 3, and here's negative square root of 3 at 2 pi over 3. So we've got pi over 3 and 2 pi over 3, and then we add another pi, that becomes 4 pi over 3, and this becomes 5 pi over 3. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And that's all of those, and I hope I did most of them right. And I hope that helps.